G'day and welcome back to Fixed Wing Friday for another week. And in my last video I mentioned about gluing stuff like this EPP, this molded EPP, and I said that you've got to use the right glue and the right technique. I've got a couple of samples that I've done up here using probably two of the most common glues that we might find for this kind of application. Now one of them is just the cheapy glue that comes in so many kits, you know, the stuff in the white plastic tubes, we've all seen it, and it's a solvent based glue. And it's kind of, you can use it as a contact adhesive as well. And the other glue I've used is hot glue. Now this is the solvent-based glue here. This is the hot glue. And I just joined pieces together down these seams here. And let's see how well it stands up. This is the solvent-based glue. You see, that's actually pretty damn good. Look, it's actually taken a lot of bend there. And although the glue's yielded a bit, it hasn't, the joint hasn't broken. That's actually a really good joint because it's flexible as well. It's not just totally solid, doesn't crack and break away. And the adhesion to the parts is really good. See, the glue itself is actually breaking, the glue bond, and it's actually staying bonded to the EPP. And when I prepared these, what I did was I got some sandpaper and I gave them a bit of a rough up, a bit of sandpaper, just ordinary old everyday sandpaper, and I used a little bit of methanol, toxic, be careful, to wipe down and get rid of the mold relief. So I didn't actually make it really rough, I just took the skin off it and then stuck the solvent-based glue. So the solvent-based glue is pretty good. I'd use that. That's pretty good. In fact, to actually pull it apart required a lot of effort. And as you can see, glue on both sides, that's a sign of a good bond to the base material. Now, the other glue I used was hot glue. And hot glue, that's pretty good. Look, I'm able to bend the material right around like that. And it finally lets go. And in fact, this time, the material broke before the hot glue. So hot glue is a fantastic glue for joining molded EPP. It's stronger than the parent material, which means that the foam will break before the hot glue will break. Now, if that's a good thing or not, I don't know. Would you rather have a model where things actually got ripped off without damaging the foam so you could re-glue them? Or would you rather have it so that it's so strong that eventually the foam yielded? That's a personal choice you have to make when you're building your model. Now, also you've got to look at which is easier to work with. Hot glue is very quick. But if you're in a cold climate, it may actually go hard before you get complex pieces together. Solvent-based glue, of course, takes even longer in cold climates. So I'd say if you're working in a hot environment, hot glue has its benefits because you'll have plenty of working time before it cools down, whereas solvent glue may go off too quickly. If you're working in a cold environment, then solvent glue will take a lot longer to go off, so you've got plenty of maneuvering time. Hot glue will go off quickly because it'll cool down really fast. So choose the glue, possibly dependent a little bit upon the temperature of your working environment. Yeah, but I want to have a bit more of a chat about glues before we go on here, because there are two basic ways that glues work. So there are two primary ways in which glues bond things together. Now the first one is physically. This is the way most glues work. It's the way your woodworking glues work, and a lot of your other glues, they work by basically, let's draw a picture of two things to be glued together, and this is a highly magnified view. There's one piece and here is another piece. Now, of course, things are never perfectly smooth, are they? So this is one piece of material, this is another piece of material. So there's always minute surface imperfections. And what happens is if we use a glue like epoxy or something like that, let's use another color so that it stands out. If we use a glue like epoxy and we fill this gap up here with epoxy, what happens is the tiny little dips and peaks and crests on the surfaces provide a surface that the epoxy can key to. It can grip around those. It's like it gets its little epoxy tentacles into all these little nooks and crannies and it grabs onto it so that you're actually sort of wedging, the glue's wedging between all the bits and holding it together. Now this is quite common in absorbent materials, like say like wood. If you're trying to glue wood together, you use a glue that will soak into the wood to a degree. This is why CA is particularly good for woods like balsa wood, which are quite soft and they absorb a lot of liquid. So if you use thin CA on balsa wood, it produces an enormously strong bond because it wicks into the wood and creates these tendrils of glue that go right into the fibers of the wood so that it really just grips so strongly. So this is another reason why when we're gluing some surfaces, we need to sand them, rough them up a bit. The more we rough up the surfaces to be joined, the more grooves and nooks and crannies there are for the glue to get a grip on. You know, imagine, for example, you're on a 45-degree slope. If that slope is glass, you're going to slide down because you can't get your fingers into anything. But if it's a rock face, or maybe it's something that's got a lot of little holes and nooks, you can get finger holds. It's what the glue does with a physical bond on a rough surface. So that's why when we're gluing our EPP, we give it a sand. It helps with the physical bonding, the physical connection between the glue and the surface you're gluing to. Very important. And of course, the rougher you make that, the better the bond. This is particularly important, as I say, for things like epoxies and for other glues, CA to quite a degree. If it's not an absorbent surface, then using a bit of CA doesn't hurt to give it a bit of a rough up, just to give it a bit of a key. Now, the other method of gluing stuff together is what we call chemical bonding. I'll write that on the board for the blind people who are watching. Chemical bonding. This is a totally different way of joining stuff. Let's assume we have two pieces of material again, and I'll just draw them as straight this time because the surface doesn't matter. It doesn't matter whether it's smooth. In fact, it's better to have it smooth if you want a chemical bond. What happens is when you apply your glue, let's use a different colour for this glue, and when you apply your glue, we won't use that colour, she's dried up, mate. Oh no, we'll use blue. When you apply your, oh man, what's going on here? All my Sharpies are drying up. They shouldn't. I haven't had them that long and I leave the lids on. Here we go. When you apply your glue between the two surfaces, something really interesting happens. Now, chemical bonding glues are usually solvent-based. You sniff them, woo, get a bit high on them. That's a chemical glue, produces a chemical bond because what it does is it actually dissolves some of the materials you're gluing together. So if we look at this, say there's two pieces of plastic and we use a chemical bond like that stuff that you get in the tubes with the AXN and the typical EPO glue, what it does is it actually melts just the surface of the items you're gluing together, dissolves it into solution, so it then sort of becomes one and the same. So the solvent melts both sides and then the bits go together, and then when the solvent dries out, you've actually got one piece of material in many cases. Now, that doesn't happen with EPO because the solvent glue doesn't actually dissolve the EPO. But in some things, like if you're gluing, for example, perspex, you can use chloroform as a glue. And people who build fish tanks and things probably know about this. You take two pieces of perspex, you use chloroform, and it melts the two pieces of perspex together and they become one. And it's a really, really strong bond. And so that's the chemical bonding. Now, there are some other types of chemical glues. There's a thing called acrylate adhesives. I'll draw this here. I can't remember how to spell it. God. Acrylate. Not cyanoacrylate, but acrylate. And that's really useful on things like fiberglass because it forms a chemical and a physical bond with two pieces of fiberglass. And that's really, really handy because it actually kind of dissolves a little bit the surface layer of the fiberglass, which means that actually, instead of just being a physical connection, there is a chemical bonding as well. It may not be a particularly fantastic chemical bonding, but it's better than just having a physical bonding. So if you want to join pieces of fiberglass or carbon fiber, laid out carbon fiber and resin together, then acrylate is a really good glue for doing so. And there's all sorts of different types of acrylate. Some work better with metals as well, and so forth. So yeah, acrylate, but you probably won't use those too much except for joining fiberglass bits together. The ones you're going to be dealing with are physical bonds, which I suppose I should write down the type of glues we're talking about. I've got room on the side. Yes, I do. Which are your epoxies. Oh, that's terrible writing. It's your epoxies, it's your CA, it's your PVA. It's like your woodworking glues, your what is it? What's the other one? Oh, I can't remember. Anyway, the other woodworking glue that I use a lot, and I can't remember it because I'm old and I'm forgetting. Those are the physical bonding glues. Now these ones, chemical, these are the solvent-based. And I'm not going to list the names because there's so many of them anyway. But if you use the wrong glue for the wrong job, for example, if you use a solvent-based glue on a material like wood, it's not going to work so well. It really won't. It will stick, but it won't stick as well. And if you use something like epoxy on molded EPP, it's not going to work well either. But there's actually kind of a third kind, or fourth kind I didn't quite mention here. In the chemical bonding, where we take two pieces of material and actually convert them into one through a chemical process, hot glue comes into it. So I can actually put hot glue in here because in some cases, hot glue becomes a chemical bond, and it does that on molded EPP, which is why the two pieces of EPP are glued with hot glue. They broke before the glue join, because what happens is, of course, if you put steaming hot glue in here, it melts the EPP on each side, and it all flows together into one, so you have a fantastic join because there's no actual glue line because the glue and the EPP sort of mix together a bit because they're hot enough to melt both, so you get a fused joint. So it's kind of a chemical and a physical bond, and that's really, really strong. That's why that worked. On the solvent glue, when we use the solvent-based glue on EPP, it did adhere really well to the foam, but it wasn't as strong as hot glue itself. So there you go. So there's just little basics of glues and when and how to, well, the type of glue, and the reason that they stick stuff together. So hope that's been useful. Let's get back to the S800 Sky Shadow. And of course, no test of glue would be complete without CA, and I've done the same process here, cleaned up the edge with some methanol, sanded it lightly, and I've CA'd it. Now, one thing I noticed about CA, it is a very stiff glue. There is no give and there's no flexibility. Both the other glues had a little bit of yield, and that's a bit of a problem sometimes when you're dealing with a flexible material. You don't want a really hard glue because you get stress rises right along the edge. It'll tend to crack and break right where the glue joins onto the plastic because you've got a stiff surface, which is the glue, connecting to a flexible surface, so bad things happen. So let's see what happens when I, see that? Yeah. CA, not the glue for this. Look, it's completely broken. In fact, it broke away from the plastic. There's very little adhesion to the molded EPP. It's, in fact, you can see I can actually peel it off here as well. So there's neither a chemical bond nor a decent mechanical bond, physical bond when you use CA. So that's a bit of a shame because we're going to have to put some things like wing covers on there and embed some carbon fibre in the wing, or in the trailing edge in these elevons here. So what we use to glue that in, I don't know. Epoxy's not going to work. Hot glue is going to be a faff, and it doesn't glue very well. Hot glue doesn't stick very well to carbon. So I don't know what I'm going to use. Don't know. I may end up using basically the cheap solvent glue in a packet like this, because I know that if you rough up the surface of your carbon tube, you do get a nice mechanical bond, a nice physical bond to the carbon, and you will get the same sort of physical bond to the thing. But it's actually an untidy glue to use for this because it doesn't look very nice. It doesn't look very nice when you use this glue. It's not the right piece. I've already got one in there. Oh no. So stick with me. The build will go ahead. Time for a little test here. You're going to try something out. I mentioned about mechanical bonds and rough surfaces. Well, what I've done here, I don't know if we can see it, I might have to go to my macro view, is I've made a whole lot of little pinholes in the edge of the foam so that we really do have a very rough surface. Not very good lighting in here to show this, but I'm hoping that now if I use some CA, it will wick into these holes and provide a much stronger joint. So I'm going to give it a crack and find out. Right, here is that thing. I've let it cure for 12 hours just to make sure it's absolutely right. Now let's see what happens when I try and bend this. Will it be any stronger than the, it is actually markedly stronger than the original CA join. So yeah, poking those pinholes made quite a difference, but even then, this time actually, yeah, the CA itself is broken. Let's take a closer look at that. There is still CA glue on both sides, but the CA itself is broken, and you might think, well, CA is not very strong, is it? Well, the problem is that what we've got here is a very rigid glue on a very flexible surface, so you're never going to get a really good result. There is flexible CA available. I could try that out, but to be honest, I think I know I'm going with hot glue for most of the EPP to EPP, but I really still don't have a clue for the carbon bits. Yeah, I'll probably just use something. Maybe I'll use epoxy and the same technique of making holes in the surface to get a key, because epoxy glues well to carbon, hot glue doesn't. So yeah, I've seen a number of other builds of this craft using conventional glues, and none of the carbon rods have come out, and I'll put some tape over them anyway, so yeah, not too concerned. But there you go, a bit of glue theory for you. Right, so here's another glue. This is the Hobby King Instaflex CA. I've used this before with great results on a number of models. It's just a bit more flexible than your regular CA glue, and so I've glued a couple of pieces of the EPP foam together with this, and we're going to try and pull it apart. And unlike the original attempt with CA, this is gluing quite well now, but it still did break. See that? See, the glue itself has let go. You can see there's glue on both sides of these two pieces, so yeah, it's still not the best. Now you're probably wondering why I've tried all these glues and nothing like Goop or other glues that people regularly use. Well, I live in New Zealand and there isn't actually a distributor for Goop or these other glues here, so I had to import them in. Glues seem to be a bit like lipos at the moment. Sometimes they'll ship them quite happily, sometimes they complain, "Ooh, can't ship, that's dangerous goods." So what do you do? Anyway, so I'm working on the shadow wing, and I have used that flexible CA for this carbon spar here. It seems to have taken really well. I'm hoping that it's going to be strong enough. There's probably not a lot of stress on here. I can't use hot glue for that, of course, because hot glue just doesn't stick to carbon. And this was going to be part of the Fixed Wing Friday video, but unfortunately I've had a heap of people in here today, and I've been really busy just talking to folk and helping them out, so I haven't had a chance to do the fixed wing today. I'm going to carry on now, hopefully get this finished today, test flight tomorrow, which will be Saturday our time, but hey, it'll still be Friday in other parts of the world, so this will be a Fixed Wing Friday in a bit, okay? But I thought I'd show you the result of the glue tests first, so you got a bit of an idea of what I'm working with here. And people outside of the bigger countries may also have to deal with the lack of suitable glues for EPP, especially molded EPP. There you go. If you've got questions, comments. Now, I should also mention that Matt Ogborn did a very interesting piece on using various glues with EPO, I think it was, or EPP. So I'm going to put a link to the video he made on this very subject himself, and you can go and have a look at that to get another idea of what works and what doesn't work with EPP and EPO foams. But in the meantime, I'll get on with getting on. Hopefully you'll see the Fixed Wing Friday for real in less than a day's time. In the meantime, thank you for watching. Time for me to get on with the build. Bye for now.